Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. August 26, 2017 will mark the 5-year anniversary of the inaugural episode of the science video series, Space News from the Electric Universe. The Thunderbolts Project created this series as an opportunity for its chief principals and many contributors to offer analysis and explanation of space science discoveries in the world today. For many years previous, members of the Electric Universe community had become increasingly aware of the remarkable predictive successes of Electric Universe theory versus those of the standard cosmology. But it's also apparent that a disturbing disconnect exists between science discovery and the direction of the theoretical sciences. Many of the most significant space discoveries, completely unexpected in standard reasoning, seem to rarely, if ever, force any meaningful reassessment of foundational theory. Other discoveries seem to have been forgotten entirely, disappearing down a memory hole and never mentioned in science literature again. Therefore, we shall now begin a comprehensive summary of the amazing content we have covered in the last 5 years. And as you will see, at every scale throughout the universe, the ability of the Electric Universe theory to both predict and explain discovery has never been more evident. In recent years, there have been unprecedented opportunities to learn about the nature and origins of one of the most mysterious objects in space, the Comet. The Electric Universe has always offered an interpretation of comets that radically differs from standard theory. Comets are not dirty snowballs. They're primordial, icy leftovers from the solar system's formation 4.5 billion years ago. Comets, as well as asteroids and meteoroids, were born far more recently, torn by electrical discharges from the surfaces of planets and moons. Because comets are not icy bodies, they do not slowly sublimate due to solar heating. Comet activity, including the production of comet jets and a cometary coma, is electrical activity. The detection of signatures of water molecules in cometary coma is due to electrochemical reactions at the comet, as we'll explain further later in this episode. In fact, the findings of increasingly ambitious comet missions have overwhelmingly confirmed the predictions of the electrical model. Combined, the list of surprises amount to the clear falsification of standard comet theory. One of the many game-changing surprises came as far back as 1996, when the Ulysses spacecraft encountered the ion tail of Hyakutake. At the time, the spacecraft was more than 360 million miles from the comet, or roughly 4 times the distance of the Earth from the Sun. The belief in electrically neutral objects in space has prevented mainstream scientists from confronting the obvious conclusion of this discovery. In order to remain intact over such a stupendous distance, rather than dispersing like a gas in a vacuum, the comet tail must carry an electrical current to confine the material and prevent its dispersal. Electric currents in space, traveling through the conductive medium of plasma, take the form of twisted filaments known as Birkeland currents, which look a bit like braided copper wire. In fact, in decades subsequent to the Ulysses encounter with Hyakutake, the Birkeland currents in comet tails have been imaged in ever finer detail, clearly confirming their electrical nature. The emission of X-rays from Hyakutake also shocked comet investigators. As Dr. Michael J. Mumma wrote about the discovery, astronomers decided to look at Hyakutake and they were shocked by what they saw. Rosetta images revealed a crescent-shaped region of X-ray emission around the comet 1,000 times more intense than anyone had predicted. We had no clear expectation that comets would shine in X-rays. Comet scientists responded with the ad hoc notion that the sun was entirely responsible for the X-rays, suggesting that the solar wind scavenges electrons from a cometary atmosphere, resulting in a recombination sufficient to generate the observed X-rays. The surprises in comet science continued and intensified. In 2001, the NASA spacecraft Deep Space One captured the finest image to that time of any comet nucleus. What scientists saw bore no resemblance to the dirty snowball of standard theory. The leader of the mission's imaging team said at the time, "It's mind-boggling and stupendous. These pictures have told us that comet nuclei are far more complex than we had ever imagined. They have rugged terrain, smooth rolling plains, deep fractures, and very, very dark material. Scientists were also stunned when they found that the flow of ions around the comet's nucleus was, quote, not centered on the comet's nucleus as scientists expected before the Borrelli flyby. But none of these findings forced any real reassessment about the nature of comets prior to NASA's Stardust mission in 2004. In fact, a microchip riding on the Stardust spacecraft was inscribed with the following pronouncement from Fred Whipple, the father of the Dirty Snowball comet model. Today, we know that comets are black and cold, consisting of ices and dust that coalesced from an interstellar cloud as it collapsed to form the solar system. So it's no wonder that scientists who subscribe to this concept were completely baffled by the Stardust findings at Comet Wilt 2. The surprises began with the comet's visual appearance, which was desiccated, complex, and rough, rather than icy and smooth. A major shock was the presence of so-called impact craters on the comet nucleus, as reported by New Scientist in 2004. That is completely unexpected because comets are believed to be loose aggregations of dust and ice that would shatter on impact. If the pits are craters, the surface of the comet nucleus must be much stronger than experts thought. NASA's Ray Newburn said of the discovery, "I don't think any of us ever really considered the possibility of impact craters. It may be a well-cemented rubble pile, but it's definitely not a loose, powdery surface." When scientists on Earth tested the Wilt 2 dust samples, what they found was so unexpected they initially thought that the early sample may have been contaminated by the spacecraft. Rather than the expected ancient interstellar grains, the Wilt 2 dust grains were much larger than expected and contained minerals such as anorthite and diopside, which require temperatures of thousands of degrees. NASA curator Michael Zelensky said of the discovery, "That's a big surprise. People thought comets would just be cold stuff that formed out where things are very cold. It was kind of a shock to not just find one, but several of these, which implies they are pretty common in the comet." Unfortunately, neither these nor the many previous astonishing comet discoveries seem to force any reevaluation of comet theory prior to the Deep Impact mission to Comet Tempel 1 in 2005. Scientists still assumed that comets were dirty snowballs that accreted 4.5 billion years ago. But the chief principals of the Thunderbolts Project felt confident that the NASA mission would only provide support for the electric comet model. Prior to the July 4, 2005 impact date for the Tempel 1 probe, Wallace Thornhill and David Talbot issued a series of predictions for the event, which were published on the Thunderbolts.info website. Because of the comet's low eccentricity orbit, they wrote that electrical interactions with the approaching probe, quote, may be slight, but they should be measurable if NASA will look for them. The most obvious would be a flash shortly before impact. And they predicted that temperatures associated with the event would be, quote, much higher than expected from impact heating. They also predicted more energy will be released than expected because of the electrical contributions of the comet. And they predicted that the impact crater left by the NASA probe would be smaller than expected because the comet is rock, more similar to an asteroid than a loose conglomeration of ice and dust. These predictions, as well as several others on the comet's composition and surface terrain, received stunning confirmation. Moments before the 800-pound copper projectile struck the comet nucleus, NASA scientists were amazed by the bright electrical flash, shortly followed by an explosion much larger than they anticipated when the impactor contacted the surface. As NASA investigator Peter Schultz said at the time, "What you see is something really surprising. First, there is a small flash, then there's a delay, then there's a big flash, and the whole thing breaks loose." Nor did the projectile leave nearly the dramatic impact crater scientists had predicted. Just one piece of evidence that the comet nucleus was much harder than NASA had expected. As reported by Universe Today, Swift scientists have seen a quick and dramatic rise in ultraviolet light, evidence that the Deep Impact probe struck a hard surface, as opposed to a softer, snowy surface. In 2011, when the Tempel 1 nucleus was re-imaged, scientists had to explain why the crater left by the projectile was much smaller than predicted. The Deep Impact team then made the extraordinary claim that ejecta exploding off of the comet somehow fell back down and refilled the crater in the near-zero gravity environment of the comet. as reported by Space.com at the time. Tempel 1's man-made crater partially healed itself as the ejecta settled and refilled part of the depression. Like every other comet nucleus imaged to date, Tempel 1 appeared desiccated and rocky, nor did the projectile produce the expected release of theoretical subsurface water on the comet. As noted by astronomer Charles Key in 2005, the material that came out was a surprise to scientists. A cloud of fine powdery material emerged, not the water, ice, and dirt that were expected. Nor did close-up images of the nucleus reveal the theoretical vents from which comet jets are supposed to emanate. As reported in the journal Icarus in 2007 by P.C. Thomas et al., it has proven difficult to identify specific landforms that can be identified as the vents discussed for many decades in classical comet literature, as it is difficult to locate them on Borrelly and Wild too. Nevertheless, when we fast forward to 2014, scientists with the European Space Agency's Rosetta mission to Comet 67P appeared to offer no meaningful revisions of comet theory, even in the face of all previous surprises. The mission to land a probe on a comet nucleus was based on the notion of comets as icy, snowy accretions left over from the solar system's formation. But the major surprises for investigators began long before the Rosetta spacecraft reached the comet. One early, puzzling detail was the comet's double-lobed shape, a mystery also found on several other imaged nuclei. Eventually, Rosetta scientists settled on the hypothesis that the comet's strange form resulted from two comets improbably colliding in a vast region of space, then somehow sticking together rather than disintegrating. But as we noted in many Space News episodes, the double-lobed form is important from an electrical perspective. As electrical engineers have always known, peanut-shaped spherules are common products of electrical discharges, as seen in this example by physicist C.J. Ransom, compared side by side with Comet 67P. As the probe drew closer, the comet's complex, desiccated, rubble-strewn terrain, which was, in the words of one Rosetta investigator, quote, dry like hell, drew increasing expressions of amazement from scientists around the world. The amazement was understandable given the complete refutation of the standard predictions for the comet's form. Consider this side-by-side comparison of images revealing the failure of comet theory over the years. On the left is an artist's rendition of the expected appearance of Comet Halley before the mission to Halley in 1986. We see a smooth, snowy surface, exactly what one expects if comets are icy accretions, whose dramatic displays result from sublimation of ices. In the middle, we see a slightly modified artistic rendition, forged leading up to the Rosetta mission. A surface that is still covered with snow and ice, but modified to reflect the completely unexpected images of dry, rocky, and complex comet nuclei. On the right, we see the actual nucleus of Comet 67P, as imaged by the Rosetta mission. It wasn't just the dryness of 67P's terrain that startled mission scientists. Closer and closer images revealed greater mysteries, as the topography of the nucleus revealed numerous planetary features, an explicit prediction of the electric universe, including mesas, rubble and large boulders, cliffs, sharp edges, wind-streaked rocks, and incredibly, even sand dunes. There was also stratification of material and evidence for complex geological layering. If comets were electrically excavated from planets and moons, as proposed by the chief principals of the Thunderbolts Project, all of the observed features are to be expected. Consider again this side-by-side comparison of a region of the 67P nucleus and the Sawtooth Mountains on Earth. The electric comet model also predicts that comet activity is generally driven by the comet experiencing voltage spikes when it moves from the relatively negatively charged outer regions of the solar system toward the sun's more positively charged domain. This perspective predicts and explains many of the Rosetta findings, including the, quote, surprising discovery of fast-moving electrons and electric fields very close to the comet nucleus, as well as the discovery of negatively charged, fluffy dust grains lofted from the nucleus. Electrical discharge activity on the comet also explains the formation of sand dunes and other unexpectedly dynamic changes on the comet's surface. As we explained in several Space News episodes, The initial observation of sand dunes was met with complete disbelief by scientists around the world. As blogger Emily Lakdawala wrote, "Other features are odd because they look familiar and yet have no right being on a comet. I've called them rhythmic ridges, but to pretty much everyone who looks at them, they look like sand dunes, which are just plain impossible on a body that has neither atmosphere nor much of any gravity." In multiple Space News episodes, we presented experimental footage, as shown here by researcher Billy Elberton, showing that sand dunes are easily created by electric fields which produce ionic winds and organized dust material. In fact, the scientific mainstream has finally begun recognizing the electrical cause of dust-raising events on comets and other solar system bodies. In a 2016 NASA-funded study, the researchers suggest an electrostatic mechanism for dust transport on many bodies, including the Moon, asteroids, and comets. A Phys.org report on the study stated that, quote, "Electrostatic processes may be responsible for the Rosetta detection of fluffy dust particles released from the surface of Comet 67P. But when considering the nature and origins of comets, one pathway that comet investigators must be willing to explore is the explanation of comet water production by electrochemical means. In recent years, Dr. Franklin Anariba, a specialist in electrochemistry at Singapore University of Technology and Design, has been presenting his thesis at annual Thunderbolts conferences. In a 5-part Space News presentation in 2015, Dr. Anariba proposed that a process of electron stripping releases O2, OH, and other chemical species into the cometary coma. The discovery of an electron density in the vicinity of the 67P nucleus is important. It can mean that the chemical O2 can absorb a negative charge through charge exchange, which is then followed by a process called protonation via solar wind at the comet. Water formation can then be explained via a series of pathways, as Dr. Anariba has outlined. This explanation, never pursued by comet investigators in the scientific mainstream, could eliminate the need for any imaginary reservoir of subsurface comet water ice, and it explains many comet mysteries, including the amazing desiccation of comet nuclei and the overabundance of so-called water production found in many cometary comas. It was a puzzle to 67P investigators why the comet was already producing an abundance of water and surprisingly rich molecules, even while hundreds of millions of kilometers from the Sun. But recent scientific papers may be moving the investigations in the right direction. A major shock for scientists on Earth was the detection of abundant molecular oxygen and so-called outgassing from the 67P nucleus. If comets are really leftovers from the solar system's formation, scientists had long excluded any possibility of molecular oxygen being trapped in these so-called primordial bodies. As reported in India's national magazine Frontline, the detection of O2 was unexpected. All the primordial oxygen molecules, which would have been there in a comet's evolution around 4.6 billion years ago, should have disappeared by now. The Rosetta's discovery of O2 in 67P CG is an astrophysical enigma. In a paper published in the journal Nature Communications, scientists Yao and Giapis essentially proposed that water molecules coming off the comet become electrically charged. Then the solar wind accelerates the charged molecules back to the comet's surface. There they pick up an oxygen atom from the surface from material such as sand, forming the detected O2. As investigator Giapis stated, "We had no idea when we built our laboratory setups that they would end up applying to the astrophysics of comets. The original chemistry mechanism is based on the seldom considered class of Elie-Radiel reactions, which occurs when fast-moving molecules, water in this case, collide with surfaces and extract atoms residing there, forming new molecules. All necessary conditions for such reactions exist on Comet 67P. However, even with the dirty snowball theory now, in the words of Nicholas Thomas, blown out of the water, scientists continue to assume that comets are primordial icy bodies that formed over 4.5 billion years ago. Following this brief summary of comet missions, in our next episode, we will explore many landmark comet discoveries, all of which seem to affirm the electrical nature and origins of comets. For continuous updates on space news from the electric universe, stay tuned to thunderbolts.info.